Hi everyone, we're going to graph this function and test for continuity at x equals 1. So this is a piecewise function, and the first thing we're going to do is test for continuity. So this is the definition of continuity, and it has to meet all three conditions for it to be a continuous function. So we're going to test the first condition. We're testing for x equals 1. That means that's your C. C is 1. So we're going to see if we even have a f of C. So we plug in f of 1. Now we have to plug it into this upper portion because that's where it equals 1. So that's going to equal 1 minus 4, which equals 3. So condition 1 is satisfied. Now we have to test condition 2. That means does the limit exist as x approaches 1? So we have to take the left-hand side and the right-hand side limits. So how you do that, you're going to take the left-hand side of the limit of 1. That means all numbers less than 1 and of f of x. And that should equal the limit as x approaches 1 from the right of f of x. So that would be this piece. So from the left, that means all numbers left of 1, we already know what that's going to be. So you plug in 1, and that's going to be, you just use that equation, that's going to be negative, that's going to be 3. Now from the right, all numbers greater than 1, we're still going to plug in 1, but we have to plug it into this one. So when you plug in, this was actually negative 3, sorry. You plug in 1, you get 3. Clearly, these two numbers don't match. They don't equal, so we don't have a limit because they don't equal, so that it doesn't equal, so does not exist, does not exist. Therefore, condition 2 is not satisfied, and therefore we don't even need to go to condition 3. Now, let's graph it and see what's going on with this. So, we start at 1, because that's our main focus here. This is where all the changes are happening. And you plug in 1. We already know when you plug in 1, you get to negative 3. So 1, 2, 3. And it can equal it, so it's closed. Also, we know our y-intercept here, this is a line, is negative 4. And the slope is 1. So the graph is to the left of this 1. Alright? Now, for to the right of 1, let's plug in 1. You still have to plug in 1 here. And you get 3. And that's what we got before. But it can't equal it, so it's open. Alright? And then let's plug in 2. 2 would go to 6. So it's 3, 4, 5, 6. And they're both linear, so you only have to plug in 2 values. And there's your graph. And what's happening here is at 1 here, this is 1. At 1, this is why it's not continuous. And condition 2 didn't hold. We have this jump going on here. So when you're going along the line, you have to stop and lift your pencil and go back up to here. And so this is called a jump discontinuity. And that's why condition 2 failed. All right, that's it. Thank you. Have a nice day. Bye-bye.